Hello and welcome. In this video, I'm going to show you how to code XGBoost in Python. And we are going to do it in a super interesting case study, which is called the affairs dataset. And overall, what we are trying to do is that we'll try to predict whether someone had extramarital affairs. Moreover, and since machine learning and particularly XGBoost can be not only predictive, but as well as prescriptive, we'll try to find the characteristics that make people not have extramarital affairs. So it's a very interesting topic. Let's try to have a look. XGBoost is the main theme of my new course on Udemy, where we really go end to end and do some hyperparameter tuning. So if you are interested and you like this video, please check on the link in the description for more information. So after this small introduction, let's get started. There is one thing that we do need to do, which is to get the dataset. So let's go to Google. And then on Google, let's just search for affairs dataset and then Kaggle. Here we go. And it's the first link. And here, very simply, you just need to download. Don't forget that you do need to create some kind of account on Kaggle, but after that, it is quite simple. Now here, and here we go, affairs. So I'm going to do Control-C, and then in the desktop, I'm just going to do Control-V. Very simple. And after that, it is set. So one thing is that this dataset, so in the acknowledgement part, this was by Professor Fair, and it is from Yale University. There is one last thing that I would like to show you, which is the initial paper that was written about this dataset. And overall here, there are a couple of things that I would like to highlight. So first and foremost, these are the variables that we'll have a look at. So the first one is how often engaged in extramarital sexual intercourse during the past year. This one will transform into a dummy variable because I think it's more interesting to predict whether someone cheated or not rather than how much. Moreover, there's also sex. One is pretty clear, male and female. There's also age, which they put into kind of buckets. So imagine between 20 and 24, then they put halfway at 22. It is set as numeric, and we'll keep it as that because I think it makes sense. And it is the same situation for number of years married. So they also put this halfway point between the buckets. Then children, again, yes or no, also very clear. And then religious. So you have from 1 to 5, which is anti and very. Now overall, this is a categorical variable. And this one could also be transformed into dummy, but I will take advantage of XGBoost excellence when it comes to non-linearity, and I'll keep it simple and I'll leave it at that. And I'll do the same thing for level of education, which again could be considered as a factor, but it is already stated as numerical. So to be very simple, and again, to reinforce that it is fine with XGBoost, even the non-linearity, we'll keep it at that. Then the occupation, I will transform into dummy variables. And then the last one, how to rate the marriage. So from 1, which is very unhappy, to 5, which is very happy. We'll do the same thing as the how religious. But let's just have a look at the occupation in itself and below in the paper. So it goes from 1 to 6. So 1 being student, 2 is farming agriculture, 3 is white collar, so sales, secretarial, and then 4 is teacher, social worker, nurse, 5 is managerial administrative, and then 6 is professional with advanced degree. Now that we have a look, so now we have a grasp of the variables, let's go back to Spider, and now we can actually start with the coding part. The first thing that we do need to do is to import the libraries. So as a comment, import libraries. And the first one is import pandas as PD. Then we also have to import XGBoost as XGB. And it is really likely that if you have not used XGBoost before, you don't have it. So please go to your command prompt and do pip install XGBoost. And next will be import SHAP, and it is the exact same situation as XGBoost. So please go to your command prompt or your Anaconda prompt and do pip install SHAP. Now with me there were some issues with installing SHAP, but one command that worked was conda install and then -c and then conda -forge and then finally SHAP. And then the last one is from sklearn.metrics, and then we import the confusion matrix. This is it. And now let's just click on F9, select everything, and let's go and get our data set. So let's set a new working directory. So for me, we go to files, and I add it in my desktop, so OneDrive. And then ambiente de trabalho is desktop in Portuguese. As you can see, I have information in English, German, and Portuguese in my laptop, so apologies for that. And here we see the affairs dataset. As a comment, retrieve dataset. And now what we can do is we'll call it data. So data equals and then pandas. Now read underscore CSV, open parenthesis, open quotation marks, and inside we do affairs.csv. Let's do F9 and have a look at our data set. So variable explorer, data, 600 observations, not a lot. And as well, we have 10 columns. The first one is unnamed and is completely pointless, so we'll completely disregard that one. So we can see you have the rating, occupation, education, religiousness, years married, age, gender, and the affairs. So what we can do now immediately is have a look at our data types. And this is to have a feeling as to what we need to transform. So data, and then we do the types, and then we just do F9. Let's have a look. So almost everything is an integer. We have gender, which is an object, age, which is a float, this is still fine, and then the children, which is also an object. And if we were to have a look, we have to transform this gender and children because these are with objects, so we'll transform them into ones and zeros. And then as well, I also want to transform the occupation bit, since it is something that the numerical form does not make so much sense. So I would like to have this one as a dummy variable. So let's kick off all the preparation of our dataset. The first thing is, as we have seen, we'll transform this occupation into categorical. So transform occupation into categorical. And it's super simple. So we want it to be still within our data and under occupation. So this is what we write on the left side. And then we do equals, and then we start with the data, then we do dot occupation, and then the last thing that we do need to do is now as type. So this is the transformation, and then in quotes category. Super simple. Here we go, F9. Now it has been transformed. If I do data dot d types again, just to have a look, we can see that occupation is now under category. Next, what I'll do is that I'll start by transforming now and isolating my x and my y variables. So isolate x and y. And this is super simple. So we'll call it x, and then x equals, I go to my data, and then I do dot iloc, open square brackets, and inside we always start with the observations, which is a colon because I want all of them, and then I do a comma. And now where is our x? And let's have a look again at our data. And here we go. So the first one we don't want, as well the second one we don't want as well. But remember that in Python, index starts at 0. So we'll have to start with the second index or the third column up until the last one. So here we go, and it is very simple, 2, and then we just do colon. And let's just run this to see, and here we go, we have the X with 8 columns. So everything is absolutely working, and now we want to create the Y. Again, data dot iloc, open square brackets, how many observations, all of them, so colon, and then comma, and I want the first index or the second column. Again, let's do F9, and here we go. We have our Y, which is the affairs, but remember that it goes from 0 to 12, so we'll need to transform this into a binary form. And as well, just to recall, we have the X from gender up until rating. So let's kick it off. Now what we need to do next is to transform the Y variable into binary. And here we go. This is super simple. We start off with a Y because this is what we want to have in the end. And then what we do is, so we use numpy or np, and then we use where, and then we start with the logical condition. Now, if the Y is bigger than 0, so if someone has had an affair, then I want a 1, and if not, then I want a 0. Let's click on F9 to run. NP is not defined, so this means that we forgot, or I forgot, to import numpy as np. Let's run. And here we go. Now we can run this part again below. Here we go. So if we have our Y over here, and here we can see that there are the zeros. And if we go below, then there are the ones. So everything is working. Now what we need to do next? Now we'll transform the categorical, so the male, also the occupation, and we'll transform this into binary variables. So transform categorical into dummies. And as well, super simple. Again, we want to transform our X, and then we do equal. We go to our pandas, and there's this super cool function, which is get underscore dummies. Open parenthesis. Now let's do Control I to have a look at what we need to include. And of course there's data, so let's immediately kick it off. So data equals X, comma. Next, there are a lot of things here, but there is one thing that I would like us to do, which is this drop first. And by doing this, it will allow us to not fall into the dummy variable trap. So again, super useful function that does this. So drop first, and then this equals true. And again, super simple and very convenient. Again, let's do F9 to run. Let's go back to our variable explorer, and in our X we can see that we have the gender, which is male, the children, which is yes, and then we have the occupation from 2 up until 7, and that the first one was omitted in order to not fall into the dummy variable trap. Now what we need to do next is to transform our X and our Y into an X test and X train. So the key idea is to transform our data set into a training and test set. And the idea here is that with our training set, we'll create a model, and then we will evaluate our model into our test set. And this is something that overall the intuition does make sense. So as a comment, transform data set into training and test set. And the first thing that we need to do is to import a function. So from sklearn.model selection, here we import the train and test split. Let's do F9 to run. And next we will create the objects that we want to in the end have after we use this function. So xtrain, and then as well x underscore test, comma, y train, and then as well y test. Super simple, equals, and then now we kick off with the train test split. Now let's see what is inside. So there's not a lot of things, but it does specify that it needs the arrays. And then there are also some options. So test size we will definitely use. And since we use test size, then we don't need to use the train size because one is the inverse of the other. And then as well, what we want to do is to use this random state. And this is just for you to have the same results as me. So let's kick it off. So arrays, this one is the X and the Y. And now what we need next is test underscore size. And this one will be equal to 0.2, comma, and then lastly, random state. And then this one equals 1502. Now let me put this to the right so we can see this better. And let's select everything and then run F9. And if we go to our variable explorer, we can see the X test, X train, Y test, and Y train. They were created and now they are here. All right, so this was all about data preparation and prepare everything. And now we do the XGBoost preparations. And the first thing is to create XGBoost matrices. And the way to do it is super simple. We'll create something called train. And inside, what basically we do is that we combine, again, the X train and the Y train. So again, XGB, and then dot, and then D matrix. Here we go. And then inside it tells us that we need the data, and as well, everything else is optional, but I also want to use the label one. So xtrain, and then label equals, and then I do y train. Here we go. And then very similar test, but let's do some copy pasting over here. So Control C, and then below we do Control V. So what we do need to change is this test part, test, and let's do Control C on the est, and then let's just copy paste to the right part. Let's select everything and run. Here we go. There's train and test over here, and now we can pursue. Next one is really about, already we focused on the XGBoost side, which is to set the parameters. And this is something that we did not particularly need to do, but I will do it so that you can see what kind of parameters there is a possibility of tuning. These are not all of them that you can tune, but they are definitely the main ones. So we do parameters. This is something that we'll create, and then we open the curly brackets, and inside, because we have to create a dictionary, and that's why I use the curly brackets. Now we start. So in quotes, learning, and then underscore rate, and then do colon, we do 0.3. Let's use the standard ones. So again, max underscore depth, and then colon, and this is 6. Here we go. The next one is col sample, and then by 3 colon, and here we do 1. Next one is sub sample. I know if you are new to this, they can sound really quite confusing, but there is a purpose to all of them. For instance, learning rate, it is the speed as to which the model will learn. As well, max depth. So how long do we want the tree to be? So mean child weight. And for instance, column sample by tree. So this is about of how many columns we want it to take. So this more or less share of columns, because XGBoost does not look at everything at once. That's what makes it really good at dealing with multicollinearity. Here is 1. And then we want as well gamma. And as well, I think minimum child weight and subsample, they're actually quite similar. So minimum child weight really has to do with the weight of the observations, because not all observations have the same weight, because there are some observations which are more difficult to predict and thus they have more weight. And subsample is really more focused on the share of observations. So one is more on the importance and the other one is more on the total. And then gamma equals 0. The next one is random state. This is really for you to have similar results as me. Then colon 1502. And then the next one is the eval metric. And we need to put the quotes first, eval metric. Now we are going to use the AUC, and this is simply because we are doing a binary, and the area under the curve is one of the key ways to evaluate logistic models or classifiers, so AUC. And then the last one is the objective. And this is literally just to reinforce that we are doing a binary problem. So we start off with binary, and then we do logistic, because there is more than one type of classification problem, because we are just doing binary, but we could try to put things in 3 buckets, for instance, and this is still a classifier problem. And this is absolutely it for the parameters bit. One word of caution is that because you're doing dictionaries, it is not really good at dealing with the spelling mistakes. So I'm going to hope that I did everything right. So please make sure that everything is correct, because otherwise it is likely that you either don't notice it because you will not get an error, or actually you just realize at the end. And we are doing this with just one model. So if you have an error, it's easy to go back. But if you realize after like 2 or 3 rounds of hyperparameter tuning, then it's not simple. But we did have an error, so in the subsample I put a comma instead of a colon. So let's run again. So fortunately for this type of error, it did work out, thank God. And now we are done. So after we have set the parameters, now finally we can actually run XGBoost. So this is the exciting bit and the way to do it. So first of all, we do the model. So this is where we'll store the results of what we are about to do. And then we go to our XGB library, and then we use the train function. And we start off with params. So params equals the parameters that we have just created. And actually what we can do is to do Control I over here and have a look. Let's also increase the size over here. And when we ask for help, so there is dtrain. So this is our train that we created previously. And then we have as well num boost round. So this is the number of times that we want our model to be run. We'll go with 10. Also, we really don't have a lot of data. And then lastly, we go with evals. So this is where our test set actually is. So quite simple. So let's kick it off. So dtrain equals train, and then we go num boost round. Now this one will be equal to 10, and then evals, and here we'll do something different. So instead of just doing the parentheses, we do the square brackets, and then we do open the parentheses, and we start off with the test, and then we will name the dependent variable, which is yes. Now, of course, you can go with something more funny to instead of yes, just to indicate whether someone had an affair, like cheating bastard or whatever. But let's run this. Let's select everything and do F9. And we can see that we got kind of like an okay area under the curve, especially considering that this is the training set. Next, now that we have run our model, we can finally do the predictions. And this is, again, quite simple. We'll call it predictions, and then equals, and then we go to our model that we have just created. We do dot, and then we do predict. And inside, we just need to include something, which is data. but it is a very specific data, which is test. And why test? Because we created a model with our training set, and now we predict using our test set. And hence, let's do F9 to run. So predictions, and let's go to our variable explorer to have a look at the predictions. Everything is between 0 and 1, but of course, it's not like someone cheated 13%. It's like yes or no. So one thing that we do need to create is that we again transform the predictions, and then we use our numpy. Now we do .where. Now if predictions, if this is bigger than 0.5, then I want a 1, and if not, then I want a 0. Why 0.5? So 0.5 is the value that maximizes the area under the curve. Of course, this is just, a metric, and it could be that you'd like something different. And for instance, you really could care about knowing which one is a cheater or not. So you could literally just decrease this 0.5. It really depends on your goal. And we can do F9. And now we can do the confusion matrix. And here we go. And when we do the confusion matrix, so we'll call it again confusion matrix. And to do this, it is super simple. We do equal, and then we use the function confusion matrix. And here we go. And what we need to include inside, so this is the y true, which is our y test. And then as well, we need to use the y pred, which is the predictions. Let's do F9. And next, what we want to print out is actually the confusion matrix. So print, open parenthesis, and then confusion matrix. Let's have a look. It ran more than actually what I wanted. And let's do F9. And here we go. And we can see that it is not so good, actually. And so if we are to do just the accuracy, we can do 8 plus 81. So 8 is the true positives and 81 is the true negatives. And how many do we have in total to check our total accuracy? So we have 8 plus 81, so that's 89, plus 6, that's 95, and then plus 26, that's 121. Here we go, let's do F9. So when it comes to accuracy, it's like 74%. But if you think about it, that's really not great because we do have 8. So 8 is the true positives. And then 26, this is the false negatives. So these are the people that cheated, but our model was not able to flag this out. And then 6, these are the false positives. So these are the ones that our model said they cheated, but actually they didn't. So overall, I'm like kind of, I don't think our model did such a great job, but I would highlight that with just a data set of 600, that's really not a lot we can do, unfortunately, to use machine learning. But then again, the key idea behind this is to show you how to use XGBoost. And again, we were focusing on prediction, but now the focus from now on until the very end will be on prescription. So we'll find out the characteristics that lead to someone cheating or not. So let's go. And as a comment, so shap values. And here we'll create something called explainer. And then we go to our shap library. And then we use the function tree explainer. And inside we need to just include model, which is model. Simple. And the next one is, okay, so this is the function that we have created that will use the model, but now we need to apply it somewhere. And we are going to apply it to our X test. So we'll create finally the shap values, and shap values equals, we go to our function explainer. Now we do dot, and then shap values over here. And inside, we just need to include the X. And the X is the X test. And here we go. And then one last thing, so shap, and then we do dot summary plot. And then inside, so first of all, we'll include the shap values that we have just created. We'll include as well the data source, which is xtest. And then we'll include how many variables we want. So max display, let's just focus on having 5. Let's select everything over here and do F9. And we go to plots and let's increase the size to see it better. Now, first thing is let's focus on the rating and how to read this. So high values, so these are in red. So in our case, high values in rating, they do mean that people are less likely to cheat. And then low values of rating, so these do mean that people are more likely to cheat. So this makes sense. Years of marriage. Now, if you have been longer married, you are more likely to cheat. Religiousness does play its role, kinda. So if you are religious, you are less likely to cheat. In terms of education, personally, I see it kind of a mix over here. And then age as well. Honestly, I think we have to go a bit deeper on these two. But definitely, when it comes to rating, years married, and religiousness, these do make sense. So this is it for this XGBoost tutorial in Python. I hope that you liked it. I know it was a bit long, but then again, even though XGBoost is accessible, there can be some preparations that you do need to do to your dataset in order to use it. If you liked it, please again reinforce to check out the link in the description about the Udemy course. And as well, please subscribe to the channel if you liked it for other videos. I am very much looking forward to seeing you soon in the next video. And until then, have fun.